Okay, so we're going to spend a little time talking about equations and solving equations. And the first thing we're going to look at is converting standard form and slope-intercept form. So fresh page of notes. We're going to go back to spend a little time just working on some notes. Get a fresh page. Your title is Converting Between Standard Form and Slope-Intercept Form. This is actually going to be part 1 of 2. Okay, so what I want you to copy down is some information about slope-intercept form. So what I want you to do is copy down slope-intercept form along with the equation. And then there are two very important pieces of information that need to be written down. This is a little bit of review, but it is important to have copied. This formula is used to graph linear equations. Okay, so when we're graphing lines with the chapter that we just looked at, you have the y-intercept that you plot, then you use the slope to find the next point. So this is called slope-intercept form because we use those two pieces of information to graph it. Okay, so right here the formula is used to graph linear equations. The second piece, this is very important. To be able to graph an equation using the slope and y-intercept, it must be in this format. And by it, I mean the equation. There's a different format that we're going to look at in a few minutes. And that format, you cannot, there's no slope and y-intercept that's obvious like that is here. So it's going to be important that you have these two pieces of information written down. This format is used to graph linear equations. To be able to graph it using a slope and y-intercept, you must have it in this format. So pause and get that copied. Okay, another note, and you don't need to rewrite this title, okay? Add this to the bottom of that last page. X and Y are... Okay, so we have X and Y on opposite sides of the equation. If you look at your Y equals mx plus b equation, the Y and the X are on opposite sides. Okay, so that's important for slope-intercept form. So just add this underneath the last two. Oops. Okay. So the next thing that I want you to write down is standard form. So you're going to learn a new form today of the same type of equation, just written a little bit differently. It's called standard form. So underneath this X and Y are on opposite sides of the equation. Write standard form. And then write ax plus by equals c. Okay, so now we've got some information about standard form, and I want you to copy these three pieces of information down. X and Y are on the same side of the equation. You'll notice it's ax plus by. So the x and the y are together. A is traditionally positive. Okay, so we usually try to keep A positive. Okay, doesn't have, if it's not positive, it's not wrong, but it's just one of those mathematical standards where the A should be positive. If you can make that positive, you should do it. And finally, A, B, and C are integers, no decimals or fractions. That is definitely something that needs to happen. You do not have something written in standard form with decimals or fractions involved. We're all integers, positive, negative, no decimals or fractions. So get all that copied down. Okay, so let's look at some steps. Today we're going to look at converting standard form into slope-intercept form. So in your notes, the next thing I want you to write, convert standard form into slope-intercept form. So what we have is what we're going to be doing is solving for y. Basically, we're taking this ax plus by equals c formula, and we are solving for the y. So we're trying to find this y. So that's what they mean when they say steps to solve for y. So how to get the y by itself. So the first thing you're going to do is add or subtract the term that is on the same side of the equation with y. So this piece right here is the first thing that we're going to eliminate, is basically eliminate the x from that left-hand side. Then the next thing is divide each term by the coefficient of y. So this b is going to get divided. Everything will be divided by that b. And we'll see an example in a second if this doesn't make sense. But definitely get all this copied. That way, as we go through the examples, you can refer back to this, the list of steps. Okay, example 1. Write in slope-intercept form. So write the word example 1. Write these directions. You'll only have to do these directions once because all your examples are writing in slope-intercept form. And then copy down this equation. X plus y equals 12. Now, just so you have a reference, the coefficient of the x and the y are each 1. If you don't see the coefficient there, it's always 1. So in this case, my a is 1, my b is 1, and my c is 12. The only reason I'm writing that down is just for notation purposes, just to keep you reminded of that there's an a, b, and c, and what they each are. Okay, so our step number 1 is to add or subtract the term being added to the y, and that's my 1x. So if this was 3 plus y equals 12, I would subtract 3 from both sides. The process does not change just because it's an x. Okay, so I'm going to subtract an x from each side. The only tricky part, on the left, my x's are eliminated and I'm left with a y. On the right, I cannot add x's with 12s. I cannot subtract x's from 12. So I need to write this as negative x plus 12. This is in y equals mx plus b format. Now the reason you would do this at all is because if you're given an equation in standard form and you're asked to graph it, you convert that to slope-intercept form and then it's easy to graph. That's all. That's the whole purpose of converting. Okay, example 2. You don't need to rewrite the directions, but do write this example down. 6x plus y equals 12. So step 1 is to add or subtract the term being added to the y. We're going to undo addition first before we undo anything else. So if I subtract 6x from each side, my x's eliminate, and I'm left with y equals negative 6x plus 12. That's it. This is now in y equals mx plus b format, and we're done. Example 3. Getting a little bit trickier. So step 1 is to eliminate our term being added. So I subtract 2x from both sides. My x's cancel, and I have 5y equals negative 2x plus 10. The other thing is you want the x to come before the constant. Remember, it's y equals mx plus b. So having that mx piece term in front is what we want to have when we write. Now, the second step that we hadn't done yet was to divide each term by the coefficient of y. This right here, if it was 5y equals 10, I would divide each side by 5, right? Right, same process happens here even though we've got x's and y's, except I have to divide every single term by 5. I don't know if you remember when we were solving equations, there was a test problem that asked if which person had done the incorrect work, and one of the people in the list or in the choices divided each term by the same number, and we talked about how that was okay. That was an okay manipulation of the problem. As long as you divide each piece or each term by 5, you're fine. So my 5's cancel and I get y. Then I have negative 2/5 x plus 2. It's your final simplified equation. Remember, this is y equals mx plus b format, so it's okay for the m to be a fraction. It's our rise over run. So this kind of answer, the fraction decimal, only holds true in standard form. Slope-intercept form, you can have fractions for sure. Example 4. Negative 4x plus 2y equals 20. Now, just because I have addition doesn't mean I subtract 4x. Because if you look at this for a second, negative 4x and negative 4x is not 0. Our goal is to eliminate the negative 4x. So to eliminate the negative 4x, I have to add 4x to each side. Negative 4x and positive 4x cancel, and I get 2y equals 4x plus 20. Divide each term by 2, and I get y equals 2x plus 10. That's it. So it's the same process. It's just like solving an equation. The same process is happening as a two-step equation. If I had negative 4 plus 2y equals 20, I would add 4 to both sides. And I would get 2y equals 24, and I would divide each side by 2 and get y equals 12. The only difference is we have an x that we're dealing with here. Okay, so the process is no different from a two-step equation other than the fact that you have to remember x's don't add to constants. Example 5. 3x minus 2y equals negative 8. Now if I subtract 3x from each side, these cancel, and you need to realize that this minus 2x is actually leaves me with an, minus 2y leaves me with a negative 2y. Okay. Now if you can see that from this, that you just bring down the negative 2y, that's fine. If not, you've got to add the opposite. So I get negative 3x minus 8, or plus negative 8, however you want to look at that. Divide each term by negative 2. I end up with y equals, now a negative divided by negative is positive 3/2 x, plus positive 4. Remember, negative divided by negative always equals positive. And there's our answer. Now it's your turn. I want you to copy down these two problems. I want you to solve them out. Show all of your work. Don't do anything in your head. It's 2 steps I'm looking for. Add or subtract the x term from both sides. Divide everything by the coefficient of y. That's all I need to see. So hit pause, try this, and let's see how you did. Okay, so check your 2 answers. On the right-hand side, you have a few options. Let me write the other if you wanted to simplify this down. Okay, so if you did well, go ahead and grab the practice page. If you did not, make sure you ask questions and get some clarification, get more examples. Let me know. Thank you.